In this video, we're going to solve radical equations. So let's look at this first example here. The square root of x equals 6. Now, I could just probably figure out what x is, right? What number do I need to take the square root of so that I get 6? And most of us probably recognize that the answer is 36. So if I take the square root of 36, I'm going to get 6. Now that's nice, but I'd like to create a way of actually solving these so that as these equations get more complicated and aren't this simple, I can follow a process. So what I'm going to do is I'm going to kind of start again. And instead, I'm going to think of a process. So if I want to solve for x, my goal is to get x by itself, right? Get x by itself. That's the goal of solving. So what I need to do is I need to get rid of the square root that's over the x, right? I need to get rid of the square root. So the opposite of square rooting is squaring. So if I raise the square root of x to the power of 2 or square it, that's going to basically um, cancel the square root, okay? But what I do to one side, I have to do to the other. So if I square the left side, I have to square the right side. So the square and the square root cancel each other out. They actually undo each other. And I'm left with x equals 36. Now, just to make sure we understand that, the idea is that square root is saying what squared gives us that number. Okay. So if we're basically squaring it when we're done, we're undoing the square root. Okay. So it's this opposites kind of relationship. Okay. So the process of getting rid of a radical is we are going to raise both sides to the index of the radical. Now, it's probably been a while since you've heard the word index, so let me refresh your memory. When you're taking the square root of something, like the square root of 9, there is secretly, we're saying to ourselves, what squared gives us 9? What, when I raise it to the power of 2, gives us 9? And the answer is 3, all right? So there is technically an index on this radical of 2 because we're saying what to the power of 2 gives us 9, okay? And I did say that the answer was 3. All right, but it can change. It doesn't have to be a 2. We could have another index like a 3. So if I said what to the power of 3 gives us 8, well, that's different. That's a 2, right? Because 2 cubed, 2 times 2 times 2, right? 2 cubed gives us 8. So if the index changes, like a 4, now we're saying what to the fourth power gives us here, let's do 16. Okay, that also happens to be 2 because 2 to the power of 4 is 16, or 2 times 2 times 2 times 2 is 16. Okay, so this is called the index. This number here is the index. And when we don't see the index, that's assumed to be a 2. So the index of 2 is so common that we just call it the square root. Okay, and when we don't see the index, we assume it's an index of 2. But when we do see the index, we're going to raise both sides to the index of the radical. Okay, so if we're talking about an in general index, like let's say, I'll say it in general then, like the nth root of x equals some number a. Okay, then to solve this, I would raise both sides to the power of n. Oops, I forgot the nth root. To whatever that index is. And that is going to get rid of the index and leave me with x by itself. Okay, so let's kind of put this into practice on this first equation here. So this is a little more complicated, and I'm going to use this process of raising both powers, or raising both sides to the index, because we're talking about a square root. I don't see the index. That means it's an index of 2. So I'm going to raise both sides to the power of 2. And what that's going to do on the left side is cancel the radical. On the right side, though, 4 squared, that's just 16. And now I can solve this like any old equation. So I'll minus 2 from both sides, which gives me 7x equals 14. Kind of running out of space, so I'll divide both sides by 7. So x equals 2. And I could check to make sure that works. And it's never a bad idea when we're working with equations to check our answer. But I could check that by plugging in 2 for x into the original equation. Wow, that was a weird square root. Let me fix that. Okay, so 7 times 2 plus 2 is going to be 14 plus 2, which is 16. Oops, I'm sorry. I wrote a 14 because I said 14, but that should have just been a 4 in the original equation. Okay, sorry, square root of 16, which does equal 4. So yay, it works. All right. So we can always check our answers. It's never a bad idea to check your answer to make sure you get it right. All right, so let's try another one. So this time I have a different index. This time I have an index of 3. It's a cube root. So on both sides, I am going to raise it to a power of 3. And what that's going to do is cancel or undo the cube root. So I'm left with just x minus 1 on the left, and on the right, negative 4 cubed is going to come out to negative 64 if you just plug that into your calculator. And then I'll add 1 to both sides, and I get x equals negative 63, which I could check. And I'm going to do that for a few of these because I want to drive a point home about it. So if I plug in negative 63, all right, let's see. Negative 63 minus 1 is negative 64. Okay, so what cubed gives us negative 64? Well, the answer is negative 4 because negative 4 times negative 4 times negative 4 is negative 64. Okay, so let me just write that down because negative 4 times negative 4 times negative 4, which is negative 4 cubed, by the way, if we're not making that connection, does equal negative 64. Okay, so it's this math I'm doing in my head. Okay, so it works. Let's try it again. Okay, now this time, I have a bunch of stuff near the square root. So when that happens, I need to get the radical by itself. So I need to isolate the radical before I even begin. So I'm going to minus 9 from both sides. So 21 minus 9 is 12. And then I'm going to get rid of that 4 in front of the radical. So I'm going to divide by 4 on both sides. So that cancels, and I'm left with the square root of x plus 3 equals 3. Now that I have the radical isolated, I am going to go ahead and square both sides. Here, I'll just use a different color. Skip the step of rewriting it. So on the left side, that's going to give me x plus 3. And on the right side, I have 9. So minusing 3 from both sides, I get x equals 6. And I could double check that to make sure it works. So 4 times the square root of 6 plus 3 plus 9. Let's see if that equals 21. Okay, so 6 plus 3, that's a 9, which when I take the square root of 9, that's going to be a 3. Timesing it by the 4 is going to be 12. And 12 plus 9 is 21. Yay, it works. Okay. Let's try it again. Okay, so for this one, I don't have to isolate the radical. It's already isolated. I'm going to go ahead and square both sides. So I'm just going to rewrite it so I can put the square in there. All right, so on the left side, I'm going to be left with 5x minus 4. And on the right side, negative 2 squared is going to be a positive 4. I'm going to add 4 to both sides, which is going to give me, let's see, 5x equals 8. Divide both sides by 5. So I'm getting 8/5. All right, let's check it. Oops, I meant to do that in green. Okay, so I know that it seems terrible to plug in a fraction, but this isn't going to end up working out too badly because that fraction will simplify nicely with the 5. So I could put the 5 over 1, right? And the 5's cancel. And I'm left with 8 minus 4, which is 4. And the square root of 4 is 2. Okay, that's a problem. They're not equal. Do you see that? It didn't work because the square root of 4 is 2. It's going to come out positive. And the reason it's going to come out positive is we are working with what's called the principal square root. It's always going to come out positive. Okay, so this doesn't work. They're not equal, which means this is not a solution. It can't equal 8/5. So the final answer in this case then is no solution. Now, I actually can see that from the original problem. I really didn't need to go through all this work. I could see that from right here. And the reason is I just finished saying that when you take the square root, it's always going to be a positive. And in my original problem, I'm saying that the square root of something equals -2. That doesn't work. I could have seen from the beginning that this isn't going to happen. That the square root of anything, we'll call it blob, can't equal a negative number. Which means from the beginning, I could have said that there is no solution. But I'm aware that when you're doing problems, especially like on a quiz or a test or in the homework, you may not remember to look. You may not remember that if you square both sides, you can solve it, right? You could go through the process of solving the whole problem. But if you get yourself into the habit of checking your answers and making sure they work, then you can catch when this isn't supposed to work. Like in an example like this, where I'm saying that the square root of some number equals -2. That's not possible. Our square roots are always going to end up coming out to a positive. Okay. Okay. So let's go ahead and try another one. Now, this one, we need to isolate the radical again, right? Just going to make a note. We're going to isolate the radical. So I need to move the x to the other side. Okay, now I'm going to square both sides. I'll go ahead and use my green pen to do that. On the left side, I'm going to be left with 4x plus 1. But on the right side, when I write 5 minus x squared, that actually means I need to distribute this. I need to FOIL this out. I need to actually multiply it out. So let's do that. So when I distribute this, let's see, that's going to be 25 minus 5x. Distributing this is going to give me minus 5x plus x. Oops, let me change that color. Plus x squared, x squared. Okay. So that's going to come out to 25 minus 10x plus x squared. And actually, I'm going to go ahead and put it in order because we're used to seeing the x squared first. So I'm going to put the x squared first, the 25 last. Okay. This is a quadratic, which means I need to get it equal to 0 because I'm going to have to factor. So I need to move the 4x and the 1 to the other side. So that's going to leave me with 0 equals x squared minus 14x plus 24. And now I'm going to factor this. Not sure how much room I have. Not much, but that's okay. We can make it work, I think. Okay, so here, let me go ahead and do a little x. So two numbers that multiply to be 24, but add to be negative 14. So positive 24, negative. Oh, so they're both going to be negative, and that should be negative 12 and negative 2. And I can use my shortcut. So this is going to give me then x is going to equal 12 because I set them both equal to 0, right? And x is going to equal 2. Okay, so there's my two possible answers. Actually, I probably shouldn't put a box around it. Let's wait and see if it actually works because I'm going to check them. All right, I'm going to check 12 and 2 into the original problem. So here, let me zoom out a little just so I have more space and I can see. Oops, maybe a little bit more. All right. So I'm going to check 12 and 2 into the original problem here. So 12 plus 4 times 12 plus 1 equals 5. Okay, 4 times 12, that's 48. Plus 1 is 49. I'm going to go ahead and do that all at once. Okay, the square root of 49 is 7. And 12 plus 7 is 19, which is not 5. So this one doesn't work. Can't be 12. All right, let's check the other one. Let's check 2. Okay, 2 plus the square root of 4 times 2 plus 1. Okay, so 4 times 2 is 8, plus 1 is 9. And the square root of 9 is 3. Okay, this one works. I get 5. All right, so the second one on my list here is the actual answer only. So the 12 won't work. And actually, that kind of makes sense if you look at what I have here in red. So ignoring the green and just looking at the red, do you see that if when I plug in 12, I get a negative on the right side, but on the left side, I have a radical? That means then I'm going to have kind of a situation I saw earlier where I can't have the square root equaling a negative number. So it makes sense that 12 doesn't in fact work. Okay, let's try one more, or actually I think we have a couple more here. So for this one, we have two radicals, but I notice that on the right side, I just have a 0. So it's always smart when you have two radicals to isolate the bigger radical, the one that's messier. Okay, that's the general rule we'll go with. We're going to isolate the messy radical. I'll put that in quotations. The messy radical. That's the general rule we'll use. Okay. But in this case, it actually works out kind of nice because when I add the square root of x to the other side, I end up getting one radical on the left side and one radical on the right side. So when I square both sides, I'm left with no radicals, 3x minus 8 and just an x. Okay, so then to solve this, I will minus 2x from both sides. Oh, sorry, 3x from both sides. I'm doing it in my head ahead of time, right? That happens, which is negative 8 equals negative 2x. Divide by negative 2. So x is 4. And I'm going to check it just to make sure. Okay. So the square root of 3 times 4 minus 8, and then the square root of 4. And let's see if that equals 0. Okay, so that's 12 minus 8. Well, here, that's just, okay. 4. And yeah, that's going to equal 0. Right? Okay, we're good. Feeling good about that one. Let's try that general idea again. So this is kind of the messiest of all the problems. Because this time, I am going to isolate the messy radical, but because it's a 1 over there on the right side, that's going to kind of make it a little bit messier. All right, that's all right. We're going to do this. We're going to tackle it, get through. So I'm going to isolate the messier radical, the bigger radical. So I'm going to move the square root of x over. And I have 1 plus the square root of x. All right, so I'm going to square both sides. Now, this is going to be kind of reminiscent of the problem we did earlier, where I'm going to end up having to FOIL. So the left side, I'm going to get 2x plus 1. But on the right side, I'm going to have to multiply out 1 plus the square root of x times 1 plus the square root of x. I hope you notice I'm using square root and radical interchangeably. Radical is kind of the more general term, where square root is when we're specifically working with an index of 2. So like if this had been a cube root, I could call it radical also. All right. So radical is like the general term, and I kind of switch between them because I want you to get used to that. All right. So just like earlier, we're going to have to distribute and FOIL here. So multiplying the 1, that's going to give me 1 plus the square root of x. Okay. And then here, oops, do it in green. There we go. That's going to be square root of x again, plus the square root of x squared. Well, the square root of x squared is just x. And we could combine the two square roots. We can add them like terms. Yeah, sorry. Let me just kind of catch up to my work here. Okay, so the square root of x plus the square root of x is 2 square root of x. There's 2 of them. Okay, so here's what I have. I have a bunch of stuff with the radical. I'm going to isolate the radical again. So I'm going to have to isolate the radical twice. The first time I isolated the bigger radical. This time I'm going to isolate the little radical. So I'm going to go ahead and minus this 1, which is going to cancel. That's nice. And this x. And that's going to leave me with x equals 2 square root of x. I could go ahead and divide by 2. Get rid of that 2 out in front. But it doesn't simplify nicely. So here's what I have. And I know that looks kind of crummy, but it's not going to be too bad when I square both sides. I'll show you. So the right side is going to simplify nice. That's going to be an x. But on the left, I'm going to have to just square the numerator and the denominator. So that's going to be an x squared over 4. Now, I just want to come back up here. We could have done it a little bit differently. Here, let me do it in blue, actually, because I'm going to check my answer in green. Or if I had been working with x equals 2 square root of x, I didn't have to move the 2. I could have just squared it right from here. What that would have done, though, is that would have given me an x squared on the left. Oops, I should be doing it in blue. Sorry. Give me an x squared on the left. And on the right, the square root is going to go away. It's going to be an x, but the 2 is going to square, and I'm going to be left with a 4. And actually, that's what I have right here on the left, because at this point, I would multiply both sides to get rid of the 4, to cancel that fraction. So it actually makes more sense to do it this way. This way is a little simpler, okay? I get to that x squared equals 4x quicker, but both ways will end up getting me to the same place. Now, oops, I should have done that in red, not green. What I have, though, my result here is I've got a quadratic because I have something squared. And I only have one way of solving that, and that is I've got to have to factor. But before I can factor, I need to get it equal to 0. So I need to move the 4x over to the other side. So that leaves me with x squared minus 4x equals 0. Okay, so now I'm going to factor. And the only way I could factor this, GCF. There's a GCF of x. So that's going to leave me with x minus 4. Okay, so there's my two things to set equal to 0. X equals 0, and x minus 4 equals 0 gives me x equals 4. Sorry, it's kind of a sad 4. All right, let's check it and see if it works. 0 and then 4. All right, so I'm going to come all the way back up here. On my screen, it's hard for me to zoom out. Hopefully you're able to see all of yours. I'm going to plug in 0 and then 4. Okay, so 2 times 0 1 minus the square root of 0 equals 1. Okay, so 2 times 0 is 0, and 0 plus 1 is just 1. Square root of 0 is 0, and the square root of 1 is 1, and 1 minus 0 is 1. Okay, it's done. It works. It equals 1. I mean, I almost could have jumped right to that from the beginning. Okay, so let's check 4 as the other one. Let's see if that works. Okay, so 2 times 4 is 8, plus 1 is 9, and the square root of 9 is 3, and the square root of 4 is 2. Okay, it works. They both work. Nice. So both of these answers are going to work. X is going to equal 0, and X is going to equal 4.